Welcome to Physical Sciences Consultorium. This video is part of the series Misconceptions About Space, where we examine ideas that feel intuitive but quietly fail when physics is applied. In this episode, we ask a simple question: is space really empty? Most people imagine space as perfect emptiness. No air, no matter, no substance of any kind, just nothing. This intuition makes sense. On Earth, when something is empty, it contains nothing we can see, touch, or hear. If there is no air, no sound, and no visible matter, we call it empty. Space seems to fit that description. But even the emptiest spaces on Earth are still crowded by cosmic standards. A vacuum chamber still contains trillions of particles. Airless rooms still have radiation, fields, and residual matter. Our idea of empty is shaped by human scale. Space operates on scales far beyond everyday experience. Distances are enormous, densities are extremely low, interactions are rare. At those scales, our intuition begins to fail. In physics, empty does not mean nothing exists. It means very low density. Space is sparse, not absent. Between stars and galaxies, there are atoms and molecules. They are spread so thinly that millions of cubic meters may contain only a handful of particles. But few is not the same as none. Space also contains dust and ionized gas. These materials shape how light travels, how stars form, and how galaxies evolve. Their presence is subtle, but their effects are measurable. Even where matter is extremely rare, radiation fills space. Light from stars, microwave radiation from the early universe, high-energy particles passing through. Radiation does not need air to exist. Space is permeated by gravitational and magnetic fields. Gravity acts across empty regions. Magnetic fields stretch across galaxies. Fields exist even where matter is scarce. These components are difficult to sense directly. They do not push on our bodies. They do not produce sound. They do not obstruct movement. To human senses, they feel like nothing at all. Our intuition equates no sensation with no existence. Physics does not. Physics asks what influences motion, energy, and structure, even when those influences are weak. Space is not an inert stage on which events happen. It interacts with light. It shapes motion. It influences the formation of structure. Its effects are quiet but persistent. When interactions are rare, they still accumulate over vast distances and long times. Small effects become significant. Weak influences become decisive. In space, scale amplifies subtlety. Instead of imagining space as a perfect void, imagine it as a vast, thin medium. Not crowded like air, not solid like matter, but not nothing either. A desert may look empty from a distance, but it contains air, particles, heat, and motion. Life exists sparsely, not densely. Space is similar, but far more extreme. Movies, images, and language reinforce the idea of emptiness. Darkness is mistaken for absence. Silence is mistaken for nothingness. But absence of sensation is not absence of reality. Space is not empty in the way we imagine. It is extremely sparse, weakly interactive, and physically active. That distinction matters. Many misconceptions about space arise from applying Earth-based intuition to cosmic scales. When physics replaces intuition, the universe becomes quieter, but richer. If this way of understanding space science is useful to you, this is exactly what Physical Sciences Consultorium exists for. In this series, we examine common intuitions and gently correct them using physics. If you found this episode helpful, please like, share, and subscribe to the PSC channel.